All right, so in 2.6, we're proving statements about angles. There are new properties. This is a new property, but it really is kind of a review because it is, once again, the reflexive, symmetric, and transitive properties, but this time for angle congruence. So we talked about um, for lengths, and now we talked about for segment congruence in 2.5, and now it's about angles. So you remember the reflexive property, the guy getting his cheeks pulled, still the same guy. So for any angle A is going to be congruent to angle A. Symmetric property, if angle A is congruent to angle B, if we have that, then it is also true that angle B is congruent to angle A. So if you know what the reflexive, symmetric, transitive means, these things just kind of go pretty easy. So it's important that you actually know that and you're not just looking in your notes every single time. So if angle A is congruent to angle B congruent to angle C, then we can go all the way across B and say angle A is congruent to angle C. We also have some other new theorems. Remember, a theorem is being proved by using already accepted statements. And the right angle congruence theorem says all right angles are congruent. That makes sense. If they all have a measure of 90 degrees, then by the definition of congruence, they are congruent to each other. Congruent supplements theorem. Okay, there's a congruent supplements theorem and a congruent complement theorem. The congruent supplements theorem basically says if the measure of angle 1 plus the measure of angle 2, we add those two angles together, and it's 180 degrees. Therefore, they're supplementary. Then the measure of angle 2 plus, oh, excuse me, I shouldn't say then yet. I got one more part. So these have to be supplementary, and angle 2 and angle 3 have to be supplementary. The measure of angle 2 plus the measure of angle 3 equals 180 degrees. Just get rid of this for now in this way. And so both this and this add up to 180 degrees. This and this add up to 180 degrees. Then angle 1 is congruent to angle 3. So these angles don't even necessarily have to be next to each other, but angle 2 is a supplement to both angles. It's what we're adding to get 3 up to 180 degrees, and it's what we're adding to get 1 up to 180 degrees, so therefore 1 and 3 have to be congruent. They have to be the same. You can save some steps in a proof by having that one down. The next one, the congruent complements theorem. A complement, remember, is something that makes, if I have angle 4 here, angle 4 and angle 5 make 90 degrees. Angle 6 and angle 5 make a 90-degree angle. So angle 5 is the complement to angle 4. Angle 5 is the complement to angle 6. So what does that say about angle 4 and 6? They must be congruent. So we can write this out kind of similar style. If the measure of angle 4 plus the measure of angle 5 equals 90 degrees, and the measure of angle 6 plus the measure of angle 5 equals 90 degrees, then angle 4 is congruent to angle 6. So if there's an angle that's complement to both of them, the two angles are congruent. All right, so now we're going to use some of these theorems to do some proofs. Okay, so when you do a proof, we're going to be doing 2 column proofs where we have our statements and our reasons. And these proofs are tough, so make sure you take good notes and bring your questions to class. Have them ready to ask. Okay, so first off, I need to plan my proof out. So I'm not just going to start writing stuff. It doesn't work that way. I have to have a thought process. I have to work through this. And I'm going to start looking at, I'm given 3 things here. Okay, angle 1 is congruent to angle 2. This angle is congruent to that angle. I mark these things. Angle 3 is congruent to angle 4. Now, when you start having multiple congruent angles here, you want to make sure that, like right now how I mark these, this angle is congruent to that angle. Sometimes you want to put a double arc here to show that angle 3 is not congruent to 2, but 1 and 2 are congruent, 3 and 4 are congruent, because 3 and 4 have the double angle congruence. But in this case, it doesn't quite apply. Angle 2 is congruent to angle 3, so we know angle 2 is congruent to angle 3. Okay, so I'm going to switch colors to make this easier for me. Angle 2 is also congruent to angle 3. And they want us to prove that angle 1 is congruent to angle 4. So I'm looking at this, and I'm kind of making a little chain in my head. I'm saying 1 is congruent to 2, 2 is congruent to 3. I know 3 is congruent to 4. Is this going to be enough for me to say that angle 1 and 4 are congruent? So it helps draw the picture in your notebook, you know, try to follow, you know, what do I have to show? What I got to show that all these, you know, this is congruent to this, I got to put all those pieces together in my proof. Okay, so I might start with, and you could list all your givens at once, but I'm gonna do it separate. I'm gonna say angle 1 is congruent to angle 2. Why is that? Given. Okay, number 2. I'm going to say angle 1 was congruent to 2. I want to say next that angle 2 is congruent to angle 3. I think that's going to be the nicest for whoever has to read my proof. It's going to make more sense to the person if they say, okay, angle 1 is congruent to 2, angle 2 is congruent to 3, and they can look up here and see that in the givens. And then I'm going to say angle 3 is congruent to angle 4. That's still another given. So far my reasons have been pretty easy, but now I'm going to try to make the claim that of what I'm trying to prove. Okay, so I want to claim that angle 1 is congruent to angle 4. Right, that's what we want to prove. That's how I'm going to end my proof, with that statement. And now I have to justify it. And why can I do that? That we're going across the 2 and the 3, and we're skipping right all the way to the 4. That's the transitive property of angle congruence. That part's not as important, angle congruence. Make sure you have the transitive property down. That's what I'd be looking for on a test. All right. Here's the next one. All right, so once again, we're going to do a proof, so I haven't even read it yet, but I know when I do a proof, I know the form. It has to be in the statements on the left. And there's other types of proofs, and we'll get to that later this year, but there's flow proofs. There are, this is what's called a 2-column proof, and they're also, I like the flow proofs, but there's also paragraph proofs, and you actually see a lot of paragraph proofs, but I think for starting, two column proofs are good for getting your ideas down. I actually, like I said, I like the flow proof, and we will be doing those. The flow proof is just takes up more space, and that's some kids hate that. If you don't mind using some paper, it's good. All right, so we get this picture. I hope I have it drawn right. And all right, so come up with the proof, draw the picture in your notebook, and start labeling what you know. So DAB, angle DAB. A is my vertex, that's a right angle. Angle ABC, ABC, this angle here, AB is my vertex, is a right angle. And then they also say angle ABC, ABC is congruent to angle BCD, BCD. So this angle is congruent to this angle. So right now I'm thinking, well, if this is a right angle and they're congruent, that has to be a right angle too. They didn't say it, but that might be something I need to show. Let's see what they're asking me to prove now. Angle DAB is congruent to angle BCD. They want me to show that this angle is congruent to that angle. And now I'm thinking, okay, it helps that I don't have to flip through my paper. I just have this in my head. I'm thinking, well, if this was a right angle, there's that right angle congruence theorem that says all right angles are congruent. So if I could show that this angle is a right angle, I'm set. So that's my first goal. Can I show that angle DCB or BCD, that angle is a right angle? And I can't do that yet. I'm going to start with this angle here, angle ABC is a right angle. It's a right angle. And that was given. My second step, I know angle ABC is congruent to well, hold on a second. I think I just had an idea click in my mind of a better way to prove it. How I was going to do it would work, but what if we, instead of showing that that was a right angle and then showing that they were congruent, that seems like it's going to be a lot more work. As I started thinking about this, it'd be a lot easier to show that these right angles were congruent, and then I could use that transitive property to say that those were congruent. It'd be a little bit faster. I know you guys like fast, but is there more than one way to do the proof? Yes. You could have done it how I first was thinking of it, but I'm liking this way better. It'll take me a step or two less. So angle ABC is a right angle. I'm also going to squeeze in there that angle DAB is a right angle. Put those on the same line under the same given. Now I'm going to use that fact that all right angles are congruent. ABC is congruent to angle DAB. All right angles are congruent. That was a theorem. If you look it up, the theorem number, I think that was in chapter 2, so it starts with the 2, and it was third theorem in chapter 2. So that's theorem 2.3. You could either write all right angles are congruent, just because if it's in your head, that's what you remember, or if you look up the theorem, you can use that. So now I have this angle is congruent to that. I'm going to use my third given. See if I can scroll up just a little bit. My third given of angle ABC is congruent to angle BCD. That was this given up here. Okay, the only reason this works is because I made a plan first that my plan was to show that if this is congruent to that, these things are equal, and this is congruent to this. Now I can say angle DAB is congruent to angle BCD. I'm set. I'm ready to go. I can make that jump for my last statement. What I'm trying to prove, angle BAB is congruent to angle BCD. And why is that? I'm going across angle ABC.
Alex Ryman.
So skipping across angle ABC, transitive property. Going across. That would be the transitive property of angle congruence, but the big thing I want, make sure you understand that's transitive property. Okay, the next one, start looking at this, and this kind of looks like right angles to me. Okay, and they say they're complementary, so if 1 and 2 are complementary, that would be a right angle. So I'm trying to prove angle 2 is congruent to angle 4. I know some measurements here, so this is a 24-degree angle. Angle 3 is a 24-degree angle. Angle 1 and angle 2 are complementary. So in my head, I'm thinking, okay, we have right angles here. Angle 3 and angle 4 are complementary. Prove that 2 is congruent to 4. All right. To do this one, I think I'm going to take the approach where I'm going to state all my givens here, I guess. If I state, then I can just use them when they pop up. It's nice to have them there right before you use them, but I think I'm going to just kind of go into using them. Angle 1 and angle 2 are complementary. Oops. Angle 3 and angle 4 are complementary. So notice these take up some room in your notebook or on your homework assignment. Reason for that, given. So far, I think every single proof we've had has started with given. So that 90% rule is right on. And from here, so angle 1 equals 24 degrees. Angle 3 equals 24 degrees. Would it be fair to say that the measure of angle 1 equals the measure of angle 3? Would those measures be the same if they're both 24 degrees, right? But why is it? What property is that? I'll pull out another color here. These are equal, right? So if angle 1 equals 24, and 24 equals measure angle 1, you're skipping across the 24. That's the transitive property. Use that one quite a bit. From here, I have their measures being equal, but it'd be nice if we knew if angle 1 was congruent to angle 3. Because then we could use that congruence complements theorem, okay? So I'm going to say not the measure, just angle 1 is congruent to angle 3. Why is that? We went from an equal sign to a congruent sign. That's the definition of that sign, that congruent sign. Definition of what congruence means is that their measures are equal. So I have angle 1 being congruent to angle 3 now. So this angle is congruent to this angle. Now, if you remember back to that congruent complements theorem, if they're complementary, right? This is saying that these angles, this is supplementary, sorry. So these angles are complementary. These angles are complementary to the same angle. Therefore, 4 and 6 are complementary. So if we come back to this example, angle 1, and could I basically call this angle 1 the same thing as put in angle 3? So it's like angle 3 and angle 2 are complementary, angle 3 and angle 4 are complementary. What do we know about angle 2 and 4? 3 is a complement to both of them. So we can say angle 2 is congruent to angle 4 by the congruent complements theorem. And this one's just it's not a proof, it just says find the measure of the angles in the diagram. I feel like I missed something now that I'm, see here, did we miss an example, some theorems in the beginning? I forgot to scroll down further. Oh, we need these theorems. Shouldn't take too long, but this is where we're going to use them. Got ahead of myself. The linear pair postulate says if two angles form a linear pair, then they are supplementary. So I'll abbreviate it. If linear pair, not very good English, but it's good for your notes. Linear pair, then supplementary. So kind of probably been using that already a little bit, and we've also been using this vertical angles theorem, but we finally put it into this chapter because we can actually prove it now. And I think there might be a proof in your book of it on page 112. It's a pretty simple proof where you just say 1 and 2 are 2 is a supplement to 1, 2 is a supplement to 3. Therefore, by the congruent supplements theorem, 1 and 3 have to be congruent. That's why it's in this section, but the vertical angles theorem says vertical angles. So vertical angles are congruent. Okay, straightforward, simple. 1 and 3 are vertical angles, they're congruent. 2 and 4 are vertical angles, they are congruent. So that's going to help us with the fourth example. Gets there? All right. So here, find the measure of the angles in the diagram given that angle 1 and 3 are congruent. 1 and 3 are congruent. I marked that. So if this is on your homework, draw the picture, mark the diagram. Not in your book, but draw it out. Angles 1 and 2 are complementary. 1 and 2 are complementary. That means that's a right angle. Find the measure of the angles in the diagram. So I look at this. What about 1 and 3? Angle 1 and angle 4. There's angle 1 and angle 4. They're vertical angles. They're two lines that intersect. So if there are two lines that intersect, the opposite angles here are congruent as well. So I look at this, 1, 3, and 4 are all congruent to each other. So if 1's congruent to 3, I'm thinking that 3 and 78 have to be a linear pair as well, right? Because these are congruent, and if this is a right angle, these are 180 degrees, a straight line, so this has to be a right angle. So this is 78 degrees, that has to be 78 degrees. That leaves, what is the measure of these ones? Well, I need them to add up to 90. So a 12-degree angle would make 80, 90 degrees. 12 degrees, 12 degrees. So notice this picture is not drawn to scale. They don't have to be, but you can still figure this stuff out. There's the homework assignment for 2.6. Write that down in your notes and have a good evening, and we can work on that tomorrow in class. Have a good night.